Any volunteers? Any volunteers? Aniruddha, would you like to volunteer? Aniruddha Joshi, would you like to volunteer? There are two Aniruddhs in the class. Aniruddha Joshi, are you there? I can't hear you.
Sir, can I volunteer?
Let other people volunteer who don't speak up. Darshan, are you there?
Yes, sir.
Would you like to volunteer and tell us how you have solved?
Mm, Sir, I assume
You have solved,
P.
right?
Yes, sir.
Okay, and your answers are?
Uh, I don't got answers.
You didn't get answers. Okay, so you tell us
मतलब,
how you've solved. Then we
yes,
will
sir.
see. Then we will see where you got stuck.
Okay, sir.
Okay.
I assume
Wait, wait, wait,
PIW.
wait. Let me just rub out and let me just draw things so that you can. Oops, it should be a nice vertical line. Okay, this is as vertical as I'm going to get. It's so difficult to draw on this. Yeah. Okay. Now you tell us how you have solved.
At evaporator, PIW,
Uh,
50, 10, 40.
After evaporator, okay.
Uh,
So
I
P is
assume P equal
50%.
to X.
Wait. P is 50%. I is 10%, and therefore water is 40%. Okay.
40%.
Now, what did you
I
assume?
assume P equal to X.
What? P of what? Kgs, moles, tons,
Kg.
grams,
Kg, kg.
kg. Units are very important. Unless you tell units, we can't dis- decide anything or we can't calculate anything. Okay. So P you have said is
Then
X. Okay.
total weight is 2X.
Okay. So total, if you write, that's 2x. Okay.
Uh, and correspondence I and W.
So 10% of 2x. Is that what you are saying?
Yes, sir.
So 10% of 2x is 0.2x,
Point 2X.
and 40% of 2x is 0.8x. Okay.
Then after cooling,
Okay. After cooling, I think
uh,
let us draw properly. Let us write it here. Okay. So there is an after evaporator. We have P, I, and W. We will need more space. Weight percent is 50, 10, and 40. In terms of kgs, it is x point 0.2, okay, 0.2x and 0.8x. Okay, now it is going to cooling,
cooling,
and
P
there is
equals to 15.
P, I, and W. Now what P?
Weight percent,
Weight percent of P is 15. Okay.
15.
Uh,
I
why do
is
you say that?
17.
Why do you say that?
Uh, so, solubility is 15 weight percent.
Right. So solubility of P in the solution at 20 degrees centigrade to which we are cooling is 15 weight percent. Therefore, P remaining in the solution. So after cooling, I will get crystals of P
Crystals of P.
and I will get a solution. I'm going to get two things. In the solution, P is 15 weight percent. Okay, now go ahead.
And I and W is 85 weight percent
Right. Together, they are going to be
together.
85 weight percent. Okay.
Uh, P is 3x by 17. kg
kg. P is what? 3x by
by 17.
17. How did you get that?
Uh,
You are explaining. So you have to tell
hmm,
how you've got for the benefit of others. How you've got this 3x by 17?
I don't remember, sir. I
You don't remember means you have done it only 2 days ago. It is not several years ago that you have done. You look at the notebook and tell us now how you got 3x by 17. Look at the notebook or look at the pages where you have solved and explain. Otherwise, how will people understand how you got
ha
3x by 17?
I and W is x by 5 and 4x by 5 means 0.2x and
Right.
0.8x.
So what you are saying is if I take this as a control volume, whatever I comes in, there is no I in the crystals of P. There is no water in the crystals of P. So all the I has to remain in the solution. So
So,
I would be 0.2x and W would be 0.8x. Is that what you are saying?
yes, sir.
Okay. And 0.2x plus
Then total
0.8x,
is
that means
total is
x
20x by 17.
is corresponding to 85%.
85%.
Correct. So 15% would correspond to x into 15 by 85. Is that what you are saying?
Yes, sir.
So then you have divided by 5. So you will get 3 and
3
you will
and
get
17.
17. Thank you. So it is, what is 3 by 17? Can you expand in a decimal form?
Uh,
Just so that we
I
don't have to write fractions.
section
You have a
0.176 and
0.176.
the remaining p is
5, let's say
crystallized.
x, right? So then
Yes,
the remaining P is crystallized. So
crystallized.
crystals of P, okay, let me write that now. Crystals of P in terms of kgs would be x minus 0.1765. So this would be
0.824.
0.835x. Okay, fine. Now,
Yes. Now it then it converts to 80% solid and 20% liquid
okay, now it is going to go to a filter.
filter.
Okay, filter, we are going to get mother liquor coming out
Mother
from the filter, and we are going to get wet cake, or
liquid
we can
cake.
say wet crystals. Wet crystals, let me write that. Okay, so wet crystals are going to contain
80% solid
crystals
and 20% liquid.
and solution liquid.
Liquid.
This solution is going to contain P, I and
R,
W,
W.
and these crystals are going to be the same. No crystals are going through the filter. So this is 0.8235
8235
x
X.
kgs. Okay, now if you the solution, if we write in
Weight
terms of
percent
weight
is same.
percent and kgs, weight percent is the same. 15 weight percent is P, I and W put together is 85%.
85%.
Okay,
Then total due, due 20% PI solution.
right.
Then
So
total moles,
so
total
these
kgs are
wet, okay, wet crystals are going to contain 80% crystals
crystals,
and 20%
20% liquid
solution. Yeah,
solution.
right. So that means
Then kgs of
80%
solution.
is going to correspond to 0.8235x, isn't it? So 20% will
Yes,
correspond to 20 by 80 multiplied by
0.2065
0.8235x. So tell me that.
0.2059.
So this total is going to be 0.8235.
Final
0.2059x. Okay.
X. Yes.
Okay. Now,
Then in mother liquor
so then the mother liquor,
uh, is difference of 20
right? P, I, and W. Mother liquor is also going to contain P, I, and W in terms of weight percent. This is also 15 weight
percent,
percent. These two
15
put together is
and
85
85.
weight percent. In terms of kgs total, if I write, so if I'm taking this as a control, if I'm taking this filter as a control volume, whatever mother liquor total, if I write here, it is 0.2x plus 0.8x plus 0.1765. That means 1.1765x.
176.
Out of this 1.1765x, 0.2059x is going along with the crystals. So whatever is coming here below through the filter paper is 1.1765 minus 0.2059. This is 0.9706x. Is that right?
Yes, sir.
Is that what you are telling me?
Yes, sir.
Okay, fine.
Then
Go ahead.
Y amount of total is
Uh,
recycled.
just a small darshan, just a small um, small help to you at this point of time. See, if you look at whatever comes out of the cooling, why not this 85% we break down further, because we
Further
know the quantities
17 and
and we
68.
know the total quantity. We know the quantity of I, we know the quantity of water, and we know the total quantity. So if I just take this percentage, I can calculate the percentage here itself. It will help me in the long run.
Yes, sir.
So can we
17.
0.2 divided by 1.1765, if you do, yeah, this would be, I would be
17%.
17% and W
And
would
W
be,
68, 68%.
yeah, 17 plus
68.
15 is 32. So the remaining 68% must be water. And this same percentage we will get here as well. So this I also is 17% and this W also is 68%. Same way here, this I is 17 weight percent and this W is 68 weight percent. So it might help you to write this also in terms of X, this also in terms of X, this also in terms of X. You might want to write this also in terms of X.
Yes.
So if we write that, let us look at the mother liquor, because that mother liquor is going to get split into two parts. It is P is 15 weight percent of 0.9706. So 0.15 multiplied by 0.9706. So this P would be 0.1456x. I is 17% of 0.9706. So this is 0.1650x and W is 0.68%. So 0.68 multiplied by 0.9706. So this is 0.66600x. So it helps to simplify things wherever they are.
Yes, sir.
Okay, now this mother liquor
Y
is split into two parts.
two parts.
One is
Purge
purge
and recycle.
and the remaining is recycled. Okay, now what are you saying? Now what did you do? You were saying
No.
why something?
Y Y amount of total kgs is
Huh.
recycled.
Okay, so recycle, if we write P, I and W in terms of weight percent, Can we say that weight percent is still the same?
Yes, same.
15,
Yes,
17, and 68.
68.
And in terms of kgs, total, if you want to write, total you are saying is y.
Y.
Okay, so
0.15y.
okay, so p
P.
is 0.15y, 0.17y,
And
and
so
0.68y. Okay,
then it adds to feed.
right. So now this is getting added to the feed. Let's do that. So we will write on top here. Right, we will write on top here. So this recycle stream is going to contain p, I, and w. In terms of weight percent, it is 15, 17, and 68. In terms of kgs, it is 0.15y, it is 0.17y, and 0.68y. Right? Now we are writing material balance at this point where the fresh feed mixes with the recycle feed. So let's write that. Okay, so this is our let's write that separately. So fresh feed, recycle, p, I, and w. Fresh feed, p, I, and w. Total in terms of weight percent, it is what? How much was that?
5.
5.5
0.5.
and 94.5.
94.5.
In terms of kgs, it is 5.5 and 94.5. Total is 100. Recycle weight percent, it is 15, 17, and 68. In terms of kgs, it is 0.15y, 0.17y, 0.68y, right? And they are mixing together and going to evaporator, right? So evaporator is here. P, I, and W. We want in terms of weight percent, this should be 50, 10, and 40, isn't it? 50, 10, and 40, right?
Yes, sir.
Now mix them together in terms of kgs. If I, sorry, it is not, it is not here.
No.
50, 10, and 40 are not here. 50, 10, and 40 are after the evaporator. Let us just mix them together. Kgs. Okay. So P would be 5 plus 0.15y. I would be 0.5 plus 0.17y. W would be 94.5 plus 0.68y. Okay.
Yes, sir.
Now after the evaporator, and total also, if you want to write, total would be 100
Total
plus
100.
y. Total, if I write total is y. Okay, now after the evaporator, right, water is going to get evaporated. We are going to get P, I, and W. Now here weight percent we want is 50, 10, and 40. In terms of kgs, in terms of kgs, if you write, this is 0.5, sorry, not 0.5,
Mm.
5.
X.
Yeah. This is 5 plus 0.15y. This is I is 0.5 plus 0.17y, right? Total, we don't know yet. Okay. But we had also assumed something about this. We had also assumed something about this stream, right? What had we assumed?
Equal to.
We had assumed that after the evaporator, it is x, 0.2x, and 0.8x, isn't it? in terms of kgs, what we had actually assumed is x, 0.28, 0.2x and 0.8x. We have got in terms of kgs we had got here, in terms of y we have got here. Now, so if you just do these two addition, 5 plus 0.5y, 5 plus 0.15y, that is p, and I is 0.5 plus 0.17y. These two put together correspond to 60%, isn't it? Isn't it, Darshan?
Yes, sir. Yes, sir.
So add them up, 5.5 plus
5.5,
5.5 plus 0.32y. 5.5 plus 0.32y correspond to
1.2x,
correspond to 60%
60%, 60%.
or 1.2x, whichever one you would like to write. But we would like to write water as well, right? Correspond to 60%. So water would be 40%,
40%.
would be 40 by 60 multiplied by 5.5
5.5.
plus 0.32y. All right. So 40 by 60 multiplied by 5.5. This is now 3.667 plus 0.32 multiplied by 40 by 60. This is 0.2133y. Right?
Yes,
Are you with me?
yes, sir.
Okay. Now water we know what is evaporated. If I am writing control volume for the evaporator, water coming in is 94.5 plus 0.68y. So water getting evaporated would be 94.5 plus 0.68y. That is what comes in, minus what remains is 3.667
6, 6, 7.
plus 0.2133y. So now we have got, I have only two variables now, x and y. Can we not equate and can we not solve? This and this are the same. This and this are the
Yes, sir.
same. This and this are the same. Can we solve?
Yes, sir.
Can you solve for y and can you solve for x now?
Yes, sir. X.
Where did you get stuck earlier?
No, uh, I don't solve further.
Why you didn't solve further? You got up to here, but you didn't solve further. Why not?
I got X and Y, but further I don't solve. X
You
equal to
so
3.23.
x is equal to 3.23 and y is equal to
Yes, 0.969.
0.969. How is that possible? Maybe there is something wrong in the solution. X has to be,
No, sir.
y has to be
Wrong.
0.969. There's something wrong. Just check your solution.
Okay, sir.
Anybody would like to solve now? You can simply say that you add them up. You add all these things up. 5 plus 0.5 plus 3.667. 5.5 plus 3.667. This is 9.167. You don't even have to solve for x and y. 9.167 plus 0.15, 0.15 plus 0.17 plus 0.2133. This is 0.533y. You can simply take the ratio, right? From here, you can simply take the ratio. This ratio would be 50%. This ratio would be, oops, this ratio would be 10%. right? So if you just take the ratio 5 plus 0.15y divided by the total 9.167 plus 0.533y multiplied by 100 must be equal to 50%, or this ratio must be equal to zero point 0.5. So 5 plus 0.15y must be equal to zero point 0.5 multiplied by 9.167. This is 4.5835 plus 0.5133, that is 533 into zero point 0.5. This is 0.2665 So if you just solve for y, it is 5 minus 4.5835 divided by 0.2665 minus 0.15. Y would be 3.575 if you want. Darshan, are you with me?
Yes, sir. Yes, sir.
Yeah, somebody was asking something. Somebody wanted to ask. Please go ahead. Please feel free. This is not a one-way class. You have to have a discussion. We have to have a discussion. Once you get y, you
Sir,
can straight away get x. Any one
sir,
of these relationships will give you x. Yes, who's speaking, please?
sir,
Who's that?
me Praveen.
Praveen.
Sir, sir, in the recycle stream, we
Huh.
get impurity more than the product. So is it still profitable to put it in the fresh feed?
Okay. So your question is in the impurity in the recycle stream. So look at this, right? So what you are saying is the impurity in the recycle stream is more than what?
Product,
More
product.
than product. Okay. So why are we recycling, right? So if you just take this control volume, okay, if you just take this control volume, how much? What is the percentage of P crystallizing out? You can call it as sort of per pass crystallization, percent per pass crystallization. Or if you take this whole plant as a control volume, what is the percent overall crystallization? Can you tell me, Praveen?
Sir, per pass is 82.35%.
Per
And
pass means you have calculated across the cooler, right? Across the cooling
yes,
part.
sir. Yes, sir.
Okay, 82 point
35%.
82.35, and overall,
Sir, I will calculate it.
uh, overall is based on the green control volume, the bigger green control volume. So 5 kgs are coming in. How many kgs are going in this wet cake? How many kgs of P are going out in this as crystals going out in this wet cake? Arya, your answer was slightly different, no, for the recycled kgs. Have you found your
Yes, but I could not find because I followed approximately the same method,
uh,
but my calculations I back checked it twice, like with the giving values. Like it happened with me, so that the first time that I was trying to solve,
mm,
when I rechecked, the values weren't fitting in. So I
okay,
did the sum again, and then I rechecked it, so it was fitting. on every stage.
Okay,
So,
suppose you take Arya, suppose you take this green control volume, the big green control volume, not the small green control volume, the big green control volume. Is the overall material balance satisfied? Means total coming in is 100 kgs, total kgs of purge going out, and total kgs of this wet cake going out. Do they add up to 100?
so I'll check that.
Check that. And also you do the material balance for P. P coming into this big control volume is 5 kgs. No P is going out in this stream. P is going out in the wet cake as a crystal as well as the adhered solution. And purge also has P. So write a balance for total P. 5 kgs must be equal to the 5 kg going out in the wet cake as well as the purge. Same way for impurity, 0.5 kgs, and same way for water. Total water going out along with the wet cake along in the purge as well as what is evaporated, that put together should be 94.5 kg. So if your all the three individual component balances and the total balances are coming out correct, then there is no problem. But if there is a error in the component balance or the material balance, then there is a small algebraic calculation error somewhere. Praveen,
Okay, sir.
overall
Yes, sir.
crystallization.
Yes, sir. Overall is 91.17%, so it is profitable.
So now you understand why we are recycling.
Yes, sir.
Same way, look at all the other problems. Look at the methanol problem. What was the per pass conversion of carbon monoxide? 18%. What was the overall conversion? Right? 96%. If we had not recycled, conversion of carbon monoxide would have been 18%. Because we are recycling, it is 96%. Isn't that a better utilization of carbon monoxide? Look
Yes,
at the
sir.
ammonia problem. What was the per pass conversion and what was the overall conversion? Look at the here there is it is ambient air, so we if you want you can even look at the overall there's no conversion per se, it is just a physical operation here. Okay, there's no reaction, but it is a conversion of P from the solution into the crystal phase. So in a sense you can think about how much of utilization of P. It has improved from 82% to 91%, isn't it? Why it has improved is because we have allowed this impurity to build up to 10%. It is 1/5 of P. Here it was 1/10 of P. We can allow this impurity to build up to the extent that it does not cause crystallization of I along with P. So what is important is the solubility of I in the solution. Right? To that extent, I will allow this impurity to be built up after the evaporator. Right now, I have not told you anything about the solubility of I. I have only told you that I want I to be 10%. So that is based on some kind of experiments, based on some solubility data, based on plant experience. You can keep on recycling and see at what level of I you start getting crystals of I as well. Right? To that extent, you can allow it to be recycled. See, the total amount recycled is only about 3.5 kgs. Fresh feed is 100 kgs. That means only 3.5% is being recycled, if you like, in terms of the percentage of the fresh feed. But it improves the crystallization from 82% to 91%. So even if you recycle a small quantity, it is helping in terms of a better recovery of P in the form of crystals.
Sir, the
Praveen, do
P
you agree?
balance.
One second, Ari.
Per-
Praveen, do you agree?
Yes, sir.
Okay. Now you have understood. Is your doubt solved? Why we are
Yes, sir.
recycling? Yeah, Ari, go ahead.
So for P balance, it is satisfying. I've
Hmm.
not done it for the water yet, but for P balance, it is satisfying.
Check for water also.
Okay, sir.
Okay, you can check later. Okay. Any other doubt? Anybody else is having any other doubt? all people are silent. That is not good. People should talk. Everybody should talk something. Maybe I'm asking wrong question. Maybe I will ask a proper question, then people will start talking. So what do you think is going to happen in the India-England test series? Who's going to win? Or did you watch Euro? Did you see the final? Or is anybody watching Olympics? Is anybody following Olympics? Maybe that will get people interested and start talking. Say something. Somebody say something. Do you have doubts? Should we go to energy balances, or should we? Do you want one more problem like this recycle problem?
So,
Sir, one more
like in
problem.
the
One more problem. Okay. Om, you had some doubts. You had any difficulties? You were wanting to solve. You had volunteered.
No, sir.
Okay. Okay. So
so like
yeah.
where would this extra error be coming? Like in the past three sums I'm facing this.
No, I think it is just some calculation mistake. It happens when you're trying to do in a hurry. But just relax, and there's just some algebraic error somewhere. So just like Darshan had an error in solving this x and y, right? He also had gone wrong in solving x and y. It is just simple two algebraic equations to be solved. Just a minor, just a small algebraic error somewhere. Instead of minus, you're taking plus or something you've typed in the calculator, some mistake in typing in the calculator. It is just somewhere, it is absolutely okay. You just have to cross check your answer with overall material balances. Okay, shall
Okay,
we go
sir.
to one more problem? Shall we take one more problem? Or shall we go to energy balances?
Sir, one more problem.
Sir,
One
one
more
more.
problem, sir.
Okay, one more
So one more
problem.
problem, sir.
Yeah, okay. So this was there in one of the exams, and it is also there, I think, in the extra problem sheets that I have given. Maybe some of you have already solved. In that case, you can volunteer and tell me the answers. Same, our ethylene oxide problem. Let us just make the life little simple. So the ethylene oxide, we have ethylene, and or let me write C2H4 or E for ethylene, and air. They are getting mixed together. Okay. They are going to go to a reactor. What are the reactions that are happening? Ethylene plus oxygen is going to give us ethylene oxide, right? So if you want to write ethylene oxide, let us just write it as C2H4O, right? So ethylene and ethylene oxide, okay? And obviously balance the reaction, half oxygen, and some amount also gets combusted to give you carbon dioxide and water. It's a high temperature reaction. So everything is in the gas phase, everything is in the vapor state. Balance this reaction as well, C2H4 plus oxygen. I need to get 2 CO2 so that the carbon balances out. I need 2 water so that the oxygen, so that the hydrogen balances out. Now I have 2 oxygen molecules and 2 oxygen atoms. So 1 oxygen molecule. So I have 3 oxygens coming. I need to have 3 oxygens to balance the reaction. And remember what we talked about, percent conversion across the reactor. We had said percent conversion was 15% and percent selectivity to ethylene oxide across the reactor. We have taken that 85%. Look at your notebooks, how we are defined percent conversion, how we had defined percent selectivity. Long back we had done, maybe decades ago, or maybe last millennium, right? You may have forgotten already, right? So what comes out after the reactor, right? Ethylene and air are mixing. So air means we are only considering dry air. We are assuming that this air is dry, no water vapor. Nitrogen and oxygen, mole percent if you want to write, it is 79 and 21. We are not considering carbon dioxide, argon. We are not considering water vapor, just for simplicity, right? So after mixing, we are going to get ethylene, we are going to get oxygen, we are going to get nitrogen. Or maybe let me write it in the same order: ethylene, nitrogen, and oxygen. After reaction, all the ethylene is not going to get converted, right? So some ethylene is going to remain unreacted. Nitrogen will not react in the reactor. Oxygen, some of the oxygen also will remain unreacted. Okay. Ethylene oxide will be formed, carbon dioxide will be formed, and water would be formed. All this is in the gas phase because it's a high temperature reaction. Everything, it's about 250 degrees centigrade. Everything is in the vaporized state. Water, everything is in the vaporized state, right? What are we going to do after this? We are going to send it to ethylene oxide removal. We are going to dissolve ethylene oxide in water. That's what we did when we were making ethylene glycol. But just for simplicity, we will say ethylene oxide removal. So we remove the ethylene oxide. Let's say we, how much are we removing? Okay, let me just tell you that. Let's say we are removing 99% of incoming. We are removing 99% of the incoming ethylene oxide. Okay. So after this, we will still have 1% of the ethylene oxide. We will still have nitrogen. We will still have oxygen. We will still have ethylene oxide. We will still have carbon dioxide. Let's also assume that water is still there. Somehow I am just removing the ethylene oxide. Actually, we take it into a water solution, but the gas coming out of this absorption in water is still going to be saturated with water because it is coming in contact with liquid water. So 100% saturation, but let us not worry about all of that. Then it goes to a CO2 removal. So in the CO2 removal, we are scrubbing with caustic or we are scrubbing with KOH, and then we are regenerating that. Let us just simplify it by saying CO2 is removed, all the ethylene oxide is removed, and all the water is also removed. Okay, because we are heating to high temperature. So what comes out, all the ethylene oxide is gone. Oops, sorry, I should not have EO here. I should have just E here. Right, ethylene is still there. Right. Okay, now all the carbon dioxide, all the ethylene oxide, all the water is removed. Okay, we are just solving a simplified problem. So now we will not have any CO2, we will not have any ethylene oxide, we will not have any water. We will only have ethylene, we will only have nitrogen, and we will only have oxygen. Now, what do you want to do with this gas?
Recycle.
Purge.
Cycle.
Purge.
Right. So we are going to take this gas, we are going to recycle, and mix it along with nitrogen and oxygen, that is the incoming air, mix it along with the ethylene. All right. Let me draw this properly. Right, this is also mixed, this is mixed, and this is mixed. Okay, now obviously if I recycle everything, there is no outlet for nitrogen, so nitrogen will keep on accumulating. We don't want that, so we will purge some of the gas. Purge gas also will contain ethylene, nitrogen, and oxygen. Right. Okay, so I will purge to the extent how much nitrogen I want in this combined feed. So combined feed, ethylene, nitrogen, and oxygen. Right. I need to tell you something about this combined feed so that you can see how much can be recycled and how much can be purged. Do you agree with that? Okay. So in the combined feed, or maybe we will write it here. So the bottom space we will use for doing calculation. We will write it here. In the combined feed, mole ratio of ethylene to oxygen is 3, and mole ratio of ethylene to nitrogen. Oh, let's do the other way around. Mole ratio of nitrogen to ethylene is 5. All right. Is everybody able to understand up to here? Has everybody understood the feed, air, combined feed? Combined feed, I will recycle to an extent that ethylene to oxygen ratio is 3, mole ratio, and mole ratio of nitrogen to ethylene is 5. All right. Yes, no. So here is what I would like you to calculate. Calculate quantities and compositions of all streams, but let's just calculate something so we can quickly understand what is the overall conversion of ethylene. That is one thing. Okay, what is the composition of the purge gas? In terms of mole percent. Third, how many kgs of CO2 are produced per metric ton of ethylene oxide produced? This our ethylene oxide, this is our product. This is what is going to be sold, or this is what is going to be converted into ethylene glycol, and polyester can be made out of that. Right? So per metric ton of ethylene oxide produced, how many kgs of carbon dioxide are produced? Can you solve now? If you want to have a break of 5 minutes, 10 minutes, you can have a break also. 5 minutes, not 10 minutes. You can have a break of 5 minutes and you can solve simultaneously. Or you can have your breakfast and solve simultaneously. Or have lunch and solve simultaneously. Or have chips and solve simultaneously. Or have some junk food and solve simultaneously. or have
Oh,
some healthy food and solve simultaneously. Whatever you want to do, solve.
so
Yeah.
we are assuming that none of the water is being uh, like when we are removing EO, none
Huh.
of the water is also being removed. We are
Yeah.
assuming that, right?
Yeah. We are
Okay.
assuming that.
Okay. So in the fresh feed, how much ethylene is being supplied? That is also like we
Mm,
can assume.
yeah. I just want you to solve these three. So you take basis whatever you like, but calculate all these three.
Okay, sir.
Again, let me just re-emphasize how we are solving, general strategy for solving. Right? First, we need to take a basis. Right? Second, we need to think about control volume. What control volume I am going to take, over which I am going to write balances. Third, reactions that we are taking, are they balanced? Right? And then whenever reactions are there, either we are writing whatever comes in minus whatever is reacted plus whatever may be generated by way of reaction is equal to whatever is going out. That is the general material balance we are going to write. We are going to write it for reactants. If it is reactant, then the reacted we will be able to write or calculate. Generated obviously will be zero. If we are writing for products, then the generation is zero. Sorry, if you are writing for product, then the reaction is zero. It is generated in terms of moles by stoichiometry, right? So don't forget these basic steps. We have talked about them long ago. Long ago. Where did we talk about them? All right. Um, long ago. Basis, right? Steps, methodology. Do you recall? We write a block diagram. Fortunately, block diagram is already written, given to you. Write the basis, then representing the information in the form of tables. That also I have partly done for you. Think about control volume. What control volume you are going to write, over which you are going to write a balance. Correct? So don't forget this general methodology for solving any problem. And recycle problems, recall how we are doing. We are breaking that recycle into two parts. All right. We are treating them as if it's a separate stream. Give stream numbers if you like. Give stream numbers if you like, so that it becomes easier for you. Maybe you want to say that this fresh ethylene is stream number 1, air is stream number 2, recycle is stream number 3, combined feed is stream number 4, after reactor it is stream number 5, is ethylene oxide is stream number 6, after ethylene oxide removal it is stream number 7, this CO2 removed, it is stream number 8. Give some names, whatever you like. After the CO2 removal, let's say it is stream number 9, recycle is stream number 10, purge is stream number 11. Now we have broken the recycle stream into two parts. So now we have to say that stream number 10 and stream number 3 are one and the same. We are going to write compositions and quantities in stream number 3 and stream number 10 to be identical. That's how we are solving our recycle problems. Or if you want to solve it in any other way, that is also fine. What we are doing is either we break this recycle stream into two separate streams, and we say stream number 3. Stream number 3, we will assume all the unknowns x, y, z, and then go forward from left to right now, and then get stream number 10, and then equate finally x, y, z to whatever we get from by doing calculation from left to right. So we are doing calculation in this manner: 3, 1, 2, 4, 5, 6, 7, 8, 9, and then get 10, and then equate 3 and 10. That is one way of doing. It is a more systematic way of doing, but it may involve more unknowns. You may do it in a different way as well. Was this problem there in the problem sheet?
Yes, sir. I have
Yes,
solved.
sir.
You already solved. Hardik also has solved. Who also has solved? Who also has said yes? They have solved.
Sir, me, Praveen.
Praveen, you have solved. Who else? Somebody also said yes. They have solved. Hardik, you said something, or who else? Who was
No,
saying?
sir, no, sir.
Achha, you didn't say. Anyway, even if Praveen, even if you have solved, so you have solved all the problems from all the sheets, is it?
No, sir, I have chosen only selective ones.
Now you can. Now you have free time, right? While other people solve this problem, you have free time. Don't play games.
No, sir, actually, I've only calculated the compositions. I've I didn't calculate the
So
these.
calculate other things, but solve other problems now from those sheets or from Himal Blaw's book.
Okay, sir.
Solve more problems. Don't waste time. Don't play games. Don't play PUBG. You play PUBG?
No, sir, not a fan.
Not a fan. Very nice. Any other mobile game fan?
No, sir, anime.
So you're a good boy, is it? Don't play games. So don't waste time. Whatever time is now available, while other people solve, you can solve some other problems. We will need volunteer for solving this problem as well. Anybody is solving? Anybody has doubts? Nobody is solving. Nobody is solving.
So we are solving, sir.
So
Okay.
we are solving.
Solving, sir.
Okay. Any doubts up to this point?
Hello, sir.
Yeah.
So could you explain how to calculate the overall conversion of ethylene? Like what talks should we take for that?
Overall means across the whole plant. What is the whole plant? This is the whole plant, right? What is the input? Where is the input to this whole plant? Input is here, right? This is whole all the blocks inside, everything. This green control volume, you have ethylene coming in, you have air coming in, and you have purge stream containing ethylene, oxygen, and nitrogen going out. Everything else is inside. Do you agree?
Yes, sir.
That's if you take ethylene conversion across this green control volume, that will give you the overall conversion. Per pass means across the reactor. Across the reactor. Whatever ethylene comes in, ethylene reacts per pass. Right? What we are told is this across the reactor per pass. That means per pass is 15% conversion and 85% selectivity. Same as the old problem when we had just started doing reactions.
Yes, sir. Thank you.
Yeah.
Sir, can you zoom out a little?
Okay. Zoom out. Yeah. Okay. Better?
Yes, sir. Yes, sir. Thank you.
Sir,
Yeah.
uh, sir,
Yeah, go ahead. I'm
am I audible?
listening. No, your
Yes, sir.
voice is
So
very
for the
faint.
third one,
Anirudh, your voice is very faint. I can barely hear you.
sir, can you hear me now?
Go ahead.
Yes, sir. For the third one, kg of CO2, I'm getting 352.94 kg.
Okay, you're telling the answers. Okay. What is the overall conversion?
Yes, sir. Sir,
Sir,
I'll calculate that.
same sir, 356 of that. What Anirudh gave answer.
Yeah.
Sir, kg of CO2, sir, produced per metric ton.
Tell me.
352.94 kg.
352.94. Can we round off? Is it worth giving to so many decimal places or so many significant digits? It's only 2 decimal places, but so many significant digits. Anirudh, you are getting 356.
No, sir, 352.94, same as Atharva.
Three answers so far.
Sir, I am also getting 356.
Sir, I'm also getting 356.
Great. First one is more important.
Sir, may I?
Yeah.
It's 60%.
60%. Okay, that's one answer. Ruchi, overall conversion.
So please can you show the whole sum again?
Ruchita. It is not Ruchi. Ruchita.
Excuse me, sir.
Yeah. 1 second. You are not writing down in your notebooks.
So no, sir, I've written down. I just wanted to see the overall conversion, the box, sir.
Overall conversion box is overall across the whole plant.
So I'm getting
Ruchita.
40.65%.
Okay. So just say 41.
Yeah, 45.
So I am getting 35%.
Okay. 35% who was getting?
So Sarthak here.
Sarthak. Okay. Sarthak, Ruchita, and Praveen, why don't you take photographs of your solution and share to each other and let each other comment on whether which is right? So much easier in class, so much more complicated in e-class. Ria, would you like to answer? You were trying to say something. No, no, you are not audible.
Sir, even I got 352.9 kg of CO2 per metric ton of ethylene oxide.
Okay, and yeah, Ria also saying same. And what about overall conversion, Amrapali? Amrapali, right? Nahin.
So calculating.
Sir, I got 356 kg.
Okay, 355, 356.
And overall conversion 28.4%.
Overall conversion, everybody is getting different. So henceforth, let's not worry about this. Let's worry about only overall conversion. We're getting all kinds of answers. We are getting 60, we are getting 35. What else we got? Nishant, how much did you get?
28.4.
28. Amrapali, what is your overall conversion? Amrapali, right? Is that your name? I mean,
Yes, sir, it's
yeah.
Amrapali.
Okay.
Sir, I'm solving. I'll tell you in 2 minutes.
Okay.
Sir, I'm getting the overall conversion as 66.8.
Okay. Shall we just say 67?
Yeah.
Somebody was getting 40 also, right? I forgot who was getting 40.
Yes, sir.
So much fun it would have been in the live actual classroom. How boring it is in this e-class. Any other answer?
Sir, 50.7% overall conversion.
50.7. Shall we just say 51?
Yes, sir.
I think looks like we are going to get all numbers from 0 to 100.
So I'm getting 40.5, sir.
At last we have one more. Of any answer.
So I'd like to change the answer from 40 to 59.
59?
Yes.
So we'll just say 60.
Yeah.
Now 40, there is only one person.
Sir, I got 69%.
69.
And kg CO2, I got 356.
Yeah, kg CO2, we are not at all bothered. Everybody is getting the same answer.
So I am getting as 60% overall
Everybody's
conversion.
same answer. Everybody's same answer. That means we don't need to solve.
So even I am getting 69%.
Okay, so 60, there is one more. 69, there is one more. 69, there is one more. All right. Abhay. Abhay, you were getting 60? No, who was saying?
Yes, sir.
And who was saying 69? Dhruti, that was you?
Yes, sir.
So I would like to change my answer, sir.
Yeah, now
So
who
to
are you? And your
60%, sir.
earlier answer was what? And your
So
new
my
answer?
first answer was 40%, sir, but it's 60% now.
Okay, so now 40, there is no taker. 60, there seem to be more popular.
So I am getting 57%, not 35.
Okay, so we will delete 35 and we will write 57. Arya, any answer from you?
Sir, calculating, sir.
Okay. We need a volunteer for solving this problem. Who would like to volunteer? Who has not volunteered so far? Alankar, would you like to volunteer? Have you volunteered any time previously for any question? Alankar, are you there?
Sir, solving I am.
Okay. Would you like to volunteer?
Sir, I am trying, not sure.
That's okay. You need not be sure. I'm not asking you to volunteer just now. I'm still giving you some more time. Would you like to volunteer or not? Who has not volunteered?
Sorry, sir. I would again like to change my answer.
Okay. So what was your earlier answer?
57. Now I got exact 60.
So 57 we will rub out. 60 we will write one more. Okay, 60 seems to be popular answer. Those who have got 28, 67, 51, 69, please check your calculations. I'm not saying just because it is a more popular answer. I have certain reasons to believe that 60 is the answer, and that certain reason being my solution, because this was an exam problem, so I have the exact solution. Oops, went to the previous problem. So who's going to volunteer? Alankar, are you ready?
Sir, actually, I am stuck in X and Y coefficient. I don't know.
Okay, will you volunteer till whatever you got and whatever you have started with?
Sir, I want some time, sir.
Okay.
Sir, same sir, 60% overall
Okay.
consumption.
Okay, so 60 seems to be more popular answer. Who else would like to volunteer?
Sir?
Alankar is not yet ready.
Hello, sir.
Yeah, Dharmik.
Sir, I got 60.4%, 60% conversion.
Okay, okay. So it seems to be more popular answer. Should we solve, or you are capable of getting answer on your own?
Sir, 2 minutes, sir.
Okay, okay. Yashodeep, would you like to volunteer? No answer from Yashodeep, who has not volunteered. Just trying to.
Yes, sir. Yes, sir.
You would like to volunteer? Great.
Solving, sir.
Okay, okay. Take your time. So material balance has to be satisfied. That means 51 people are here today. So that means 40 people are going to watch the recording, or 40 people are going to watch the cricket match. Material balance of people also have to be satisfied. 51 of you are there today. Rest 40. Are they going to watch recording?
Sir, even I am getting 60% overall conversion.
Okay. Thanks, Mayur. Yashodeep, are you ready?
No, sir.
So can I
You
volunteer?
Hardik, I want people who are silent in the class. They should volunteer. So Yashodeep, would you like to tell us how you have started? Maybe you have not got up to the final answer, but you must have started somewhere and you must have been doing some calculations. Can you tell us where you started? Yashodeep, are you there or not there?
Yes, sir.
So tell now where you got, where you have started, what have you done, what calculations you have done so far. Yashodeep, have you done calculations or not done calculations? Any kind, you may not have got the answer. That's okay. Last time Darshan also did not get the answer, but he told us how to do it, right? Oh, come on, Yashodeep, are you there or not there? I mean, you are volunteering or not volunteering? Chha.
No, sir.
Oh, you said yes, you are volunteering, no? Okay. Who else? Prashasti, would you like to volunteer? You have not volunteered any time, I think. Prashasti, are you there? Looks like people are too shy. They don't want to speak up. Alankar, are you ready to volunteer? Are you ready to tell us how you have solved?
No, sir.
You have started, Alankar? You have not started at all? Alankar,
Sir,
keep your mic unmuted and talk to me.
sir, I am started, but I don't know what I do next.
Fine. You have fine. You have started, right? So would you like to tell us where you have started, how you have started, so that other people can benefit?
Okay, sir.
Okay, so tell me where you have started.
Sir, mole ratio of E per O2 is 3. So
Okay.
I am taking,
You are
sir, in
taking what?
combined feed.
Okay, in the combined feed, what are you taking?
Sir, E as a X.
E as X. Okay.
Then, sir, the mole ratio of O2 is X by 3.
X by 3. So shall we just say 0.33x?
Yes, sir. And
Okay.
mole ratio of N2 is 5x.
5x. Alankar, just one suggestion. Rather than taking X, what is the basis that you're taking? Are you
Sir,
taking
actually,
basis as X moles of ethylene in combined feed? Is that your basis?
I am stuck in basis. Not.
Basis means what is the starting point for your calculation? Starting point for your calculation is X moles, right?
Yes, sir.
So why not, rather than introducing an unknown just now, why not say that your basis is 1 mole of ethylene in the combined feed? That
Okay,
will
sir.
get rid
Okay.
of one unknown. So then this would be
Yes.
1, this would be 0.33, and this would be 5
5.
in terms of gram
And
moles.
total is 6.33.
Better, why do you work in fractions? Why not say 1 gram mole of oxygen as basis in the combined feed? Then I will have 1 I will have 3 and I will have 15.
Okay, sir.
Is that not a better basis? I mean, there's nothing
Yes,
wrong
sir.
in your basis as well. So we will solve with your basis. So we will solve with x. We will solve with 0.33x, and we will solve with 5x. So our basis is x gram moles of ethylene in the combined feed. Okay, now tell us. Go forward.
And total is 6.33.
Okay, totally 6.33. This is in terms of gram moles, right? Or kilomoles? What have you taken?
Sir, gram mole.
Gram moles. Okay.
And
Okay, now
sir,
tell us further.
after reaction, I am get confused, sir. Actually, what?
After reaction, what is the
Yes, sir.
reaction? Ethylene plus
Sir,
half oxygen. This is the first reaction, giving us ethylene oxide. And second reaction is ethylene combining with oxygen to give us
oxygen,
carbon dioxide
carbon
and
dioxide.
water. Have you balanced the reaction? Are these reactions balanced?
Yes, sir, balanced.
Okay. Now what is given? Percent conversion of ethylene across the reactor is 15%. So if across the reactor means across this control volume. So if X come in, how much of X is going to react?
15%.
15% of X is going to react. How much will remain unreacted?
Sir, wait, 3 by 20 minutes.
15% reacts. How much will remain unreacted?
Sir, 17 by 20 X.
85%. 85%.
Okay, yes, sir.
That means 0.85x. If you write in terms of fractions, it's just more complicated. Why not write it in the decimal form?
Okay, sir.
Nitrogen?
Same. 5x.
5x. Ethylene oxide produced?
Ethylene oxide. It's 0.85.
0.85. 0.85 or 0.85x?
0.85x.
0.85x. How much ethylene has reacted?
15%.
Ethylene gram moles of ethylene reacted. How many gram moles of ethylene have reacted? 0.15x.
Yes, sir.
15%, right?
And
has all of it given you ethylene oxide?
No, sir.
How much of ethylene has reacted to give you ethylene oxide out of this 0.15x? What does the word selectivity mean?
85%.
85%. So ethylene oxide would be 85% of 0.15x. Because 1 mole of ethylene is giving me 1 mole of ethylene oxide. Is that right? Alanka, is
yes,
that right,
sir.
Alanka?
Yes, sir.
Okay, how much carbon dioxide would be produced?
Sir, actually, I am stuck there. Actually, water is also formed. That's why.
Gram moles of ethylene reacted is 0.15x. Out of this 0.15x, 85% has reacted via reaction 1 and 15% have reacted via reaction 2. Do you agree with this?
Yes, sir. Yes, sir.
Alankar, do you revise whatever lectures? Do you see the recordings or you don't see the recordings? Do you solve problems on your own? or you don't
Yes,
solve
sir.
problems on your own?
Sir, solving, but
This
uh,
problem, material balance for ethylene oxide, have we not solved long time ago?
yes, sir, solved.
Do you recall? Where did that go? Yeah, did you not recall this problem that we solved? It is the same problem. It is just simplified version. There here it was 10 and 85. Now it is 15 and 85. Alankar, are you with me?
Yes, sir.
Don't mute your microphone. Keep on talking to me.
Okay, sir.
So gram moles of ethylene reacted via reaction 1. This is 0.85 multiplied by 0.15x. And gram moles of ethylene reacted via reaction 2 is 0.15 multiplied by 0.15x. Do you agree with that?
Yes, sir.
Yes. So 1 mole of ethylene that reacts to give you ethylene oxide by reaction 1 mole of ethylene oxide is formed. So ethylene oxide is 85% of 0.15x. That means it is nothing but 0.85 multiplied by 0.15x. Carbon dioxide now. 1 mole of ethylene gives us 2 moles of carbon dioxide. How much ethylene has reacted in the second reaction? 0.15 into 0.15x. So carbon dioxide form would be 2 times 0.15 multiplied by 0.15x. Do you agree with that? And
Yes, sir.
water formed would be 2 times 0.15 multiplied by 0.15x. Do you agree with that?
Yes, sir.
Okay, now how much oxygen has reacted? In the first reaction, what is the stoichiometry? 1 is
half.
to half. So
0.5.
oxygen reacted would be half of 0.85
0.5
into 0.15x. That is from the first reaction. Plus in the second reaction, stoichiometry is 3 times. So it is 3 times 0.15 multiplied by 0.15x. Do you agree with that?
Yes, sir.
So how much oxygen is left? 5x. Sorry, 0.33x.
Minus
all
oxygen.
these things. Can you simplify and tell me?
Yes, sir.
Simplify this 0.85 into 0.15x, 2 into 0.15. Simplify for carbon dioxide also, and ethylene oxide also, and water also, and oxygen also. Simplify in terms of x and tell me. Don't unmute your mic. Keep it on.
Okay, sir.
Otherwise, you will not talk to me. I have written down for you in terms of gram moles. Just check whether you are getting the same thing. check whether you are getting the same thing. I have already written down, but you check for yourself and tell me. Got it, Alankar?
Yes, sir. Sir, wait. Yes, sir. Got it.
They're all okay?
Sir, O2 0.18. Okay, sir.
This is correct.
Yes, sir.
Ethylene oxide.
Sorry. Point not eight.
This is not correct.
Sir, correct.
Okay.
Correct.
CO2.
Sir, correct.
Water.
Correct.
Okay. Other people are also calculating or not calculating? They're only watching or they're playing games. Other people are doing, not doing?
Calculating, sir.
Calculating. So if anybody finds anything wrong, please ask. Okay, now, Alankar, let's go forward. Ethylene oxide recovered. How much ethylene oxide is recovered?
Sir, 0.99%.
0.99% or 99%?
Sorry, sir. 99% is removed.
0.99% or 99% or 0.99? Are they same or are they different?
Sir, different.
So which one is it?
Sir, 99% is removed.
99% is removed. So how much is removed?
1%. Say 1% is
remaining. So tell me how much is remaining and how much is removed?
Sir, wait. Sir, 0.0012x is remain.
0.0012x
is remain.
1275. Na? So let us round off 128 maybe at least. Or you won't write 1275, you write 1275. Why are you rounding out to 0.0012?
Okay.
No, not okay. If you are writing 0.001275, if you are writing that as 0.0012, how much error you have made?
Sir, 1.3, sorry.
Huh? How much percent error have you made? Percent error is 0.001275 minus 0.0012 divided by 0.001275 into 100. That is the percentage error. Tell me, how much percentage error have you made?
Sir, many.
Huh? Calculate.
Sir, calculating.
You are calculating. You have a calculator.
5.9.
5.9. Is it a good idea to make an error of 5.9%?
No, sir.
No. So shall we just round off anything that we like?
Yes.
Why
Sir.
not round off 0.001275 to 0.001 or 0.001275 to 0.00? This is better, no? Or not good?
Not, sir.
Or if you round off to 0.00125, if you round it off to 0.00128, how much error you have made? 0.00125 minus 0.00128 divided by 0.00125 into 100. How much error have you made?
Sir, calculating. Sir, 0.39.
0.4%. Is that okay?
Yes, sir.
This is good. Okay, so if you want to round off, yes, you can round off to 0.00128. Okay, now
And others are same.
others are same, right? Excellent. So 0.85x, 5x, 0.1988x, 0.045x, 0.045x, and ethylene oxide that is going in stream number 6 as product, it is 0.1275 x minus 0.00128x. This is 0.00, sorry, not 00, 0.1262x. Is that okay?
Yes, sir.
Okay, now go forward. From
Sir,
stream number 7, go to stream number 8 and go to stream number 9.
Sir, all CO2 and CO and H2O removed. So,
Correct. So CO2 is 0.045x, EO is 0.00128x, water is 0.045x. So what remains in terms of gram moles?
sir, they are same.
They are same. Ethylene, nitrogen, oxygen in terms of gram moles. Ethylene is 0.85x, nitrogen is 5x, oxygen is 0.1988x. Okay, now go forward.
And after they are purged, sir.
Now
The purged.
what is going to remain same? Composition is going to remain the same of stream number 9, 11 and 10.
Where it is?
Yes or no?
No, sir, not gram moles.
Gram moles will not remain them. I'm saying composition in terms of mole percent.
Sir, yes, sir. They are remain same.
So now tell me the total here, total moles here, and calculate the mole percent here. 0.85 plus 5 plus 0.1988.
5.97.
Huh? 0.85 plus 5 plus 0.1988. Add them up. Add total. How will you get total?
6.0488.
How did you get 5.97?
So sorry, I am actually using mobile calculator. That's
Now you can use anything. You can use mobile or you can do manually, anything you like.
Okay, sir.
Now tell me in terms of mole percent. Ethylene 0.85 divided by 6.0488. How much is in terms of mole percent?
0.1396. Sir. Sir, 13.96%.
0.85 x divided by 6.0488x into 100. How much is that?
13.96.
X will cancel out. 0.85 divided by 6.0488 into 100. Do it.
Sir, 13.96%.
No, do it now. Do it again. 0.85 divided by 6.0488.
Sorry, 14.05.
How did you get 13.9?
Oh, calculation mistake, sir.
Oxygen and nitrogen. Nitrogen 5x divided by 6.0488x into 100.
82.66.
Excellent. Very good. Oxygen 0.1988x divided by 6.0488.
Sir, 3.823. 29.
29.
3.29.
Okay. Now purge, can we say mole percent wise? They would be same. 14.05, 82.66, 3.29. In the recycle, ethylene, nitrogen, and oxygen in terms of mole percent, can we say the same? 14.05, 82.66, 3.29. Now suppose I say in terms of total moles, suppose I say total moles, Y is getting recycled, then ethylene getting recycled would be 0.1405 Y, nitrogen would be 0.8266 Y, oxygen would be 0.0329 Y. This total would be 6.0488 minus Y.
Sir, X minus
yeah,
Y.
6.04. Yeah, correct. X is there. Yeah. 6.0488x minus Y, and then we can calculate this, and this, but we don't need that just now. Let's go back to this recycle stream. Now this Y is coming. This is coming in stream number 3. It is getting mixed with stream number 1 and stream number 2. I don't know anything about stream number 1. Can we say in terms of gram moles, A gram moles are coming and total B gram moles of air are coming? So nitrogen would be 0.79 B, oxygen would be 0.21 A. So now, if I mix stream number 1, stream number 2 and stream number 3, what will I get in stream number 4? Stream number 1, stream number 2, stream number 3, I am mixing and I am getting stream number 4. If I mix stream number 1 plus stream number 2 plus stream number 3, what will I get? Ethylene, nitrogen and oxygen. Ethylene is A plus what comes from recycle. What comes from recycle?
0.1405 Y.
0.1405 Y. Stream number 2, nitrogen, 0.79 B. 0.79 B plus 0.8266 Y. Oxygen 0.21 B plus 0.0329 Y. In terms of gram moles, is that okay? Yes or no?
Yes, sir.
Okay. Now, we had already assumed this in terms of X, isn't isn't it? For stream number 4.
Yes, sir.
So
They
this
are equal.
must be equal to
X.
x 5x
Next,
0.33 x. Total is y and total is 6.33x. Can you solve?
Sir, after that I am not solving, sir.
Why? Why you are not solving?
Sir, I am stuck.
Stuck where?
Sir,
Solving algebraic equations you are stuck?
no sir, I am stuck. सर मैं पहले ही स्टक हो गया था इससे पहले.
Okay, now you come up to here and now you solve.
Yes,
Okay,
sir.
so shall we stop here for the day?
Okay, sir.
So Alankar,
Yes, sir.
instead of taking this as x, see right now how many unknowns we have?
Sir, 4.
We have 4 unknowns: a, b, y, and x. 4 unknowns are there. But I have only 3 equations, right?
Yes, sir.
So I will not be able to get an answer. So rather than assuming x, would it not be a good idea? Rather than assuming x, would it not be a good idea to assume this as 1, 5, and 0.33? Then that x will not be there, no? So basis is not x now, basis is 1 gram mole, isn't it?
Okay, sir.
Would it be easier?
Yes, sir. It's
We
easier.
will have 1 unknown less, isn't it?
Yes, sir.
So solve everything now, assuming that x is 1. So all I have to do is just say is x is 1. Right, something was there here, isn't it?
Yes,
Then
sir.
x is just 1. Now I can get an answer for a, b, and y.
Yes, sir.
Okay, so will you try now?
Yes, sir. Try.
Thank you that you have volunteered. Well done. Otherwise, your doubts
Thank
would
you.
have remained with you.
Yes, sir.
Okay,
Thank you,
so
sir.
let's stop here for the day.
Okay,
Some
sir.
homework I need to give you. You have a long weekend, Saturday and Sunday. Homework, right? Read about things like specific heat. What are the units? What are the values? We talked about specific heat when we were talking about units, right? We had said units of specific heat are in terms of joules per kg Kelvin, or it can be calories per kg Kelvin, or kilocalories per kg Kelvin, any energy unit, any mass unit, and temperature unit. Or we could write in terms of moles, joules per gram mole Kelvin, or calories per gram mole Kelvin, right? So what is the meaning? What are the values of specific heat for different components, right? What are the commonly components that we encounter? Nitrogen, oxygen, water, right? It will also depend on the state. Cp of water in the vapor state is going to be different than Cp of water in the liquid state. Okay? Read about that. Second, read about latent heat of vaporization. What are the units? joules per kg, latent heat of vaporization, energy per unit mass, right? Or kilocalories per kg, or calories per gram, or joules per kilomole, kilocalories per kilomole, calories per gram mole, any energy unit, and either it could be mass basis or mole basis. Find out latent heat of vaporization for different things. Most often we will require that for water, right? Next, right? What else? What else do you need to do? Okay, at least find out about these: latent heat of vaporization and latent heat of solidification, melting. Right? What is the heat required for melting 1 kg of ice? That is latent heat of melting or fusion. That's what we call, right? Latent heat of fusion. Liquid going to gas. Sorry, liquid going to solid. That's fusion. Right? Latent heat of fusion, latent heat of vaporization. Right? So think about third thing. Think about energy, whether it is required or energy is given out during phase change. Means during water going from liquid to vapor, is it energy is required or energy is given out? Water, liquid water becoming solid, is energy required or is energy given out? I need to take out energy. Required means energy to be supplied. Do I need to take out energy or do I need to supply energy when water becomes liquid water to solid water? When I melt ice from solid to liquid water, do I require to supply energy or do I require to take out energy? Water vapor becoming liquid water, do I need to supply energy or do I need to take out energy? Right? So that's your homework for Saturday, Sunday, Monday, Friday, Saturday, Sunday, Monday. We will meet on Tuesday as usual. Shall we stop for the day?
Okay, sir.
Okay.
Sure, sir.
Bye.